Hello guys, welcome back to Easy TechNest. In this lecture, we'll continue with the few more topics in Module 2 of Embedded System Design. Today, we'll discuss about the automotive communication bus. There are three communication protocols that we need to discuss. So the first one is Control Area Network, also called as CAN. It was proposed by Bosch. It supports the medium speed 125 kilobits per second and high speed of 1 Mbps per second or megabits per second, and it also supports error handling in the data transmission. It is mainly employed in safeties like airbag control, engine control, and anti-lock brake system. Next automotive communication bus is Local Interconnect Network, also called as LIN. It is a single master and multiple slave communication interface, and it allows master communication triggering technique to eliminate the possible bus attribution problem. So the next one is Media Oriented System Transport, also called as MOST bus. It is targeted for high bandwidth automotive multimedia networking, and it is an optical fiber cable connected between the EOC, that is the electrical optical converter, and the OEC, optical electrical converter, which transmits the or translates the optical cable MOST bus. And the next topic is automotive domain specific examples of embedded system. So in this we are considering an automotive embedded system, which could be a car or any other vehicle. So the inner working of automotive embedded system is it has a mirror and wiper control and also complex airbag controller along with the anti-lock brake system. So next we'll discuss about the classification of electronic control unit, that is ECU. It is classified into different types. So the first one is high speed ECU, that is these are deployed in critical control units that requires fast response, and it's used in fuel injection system, anti-brake system, as well as in the engine control, and it is also used in washing machines. When the water is pumped, there are certain calculations that need to be carried out, that is the number of rotations per minute, that is called the spin phase. So this you can study. I'll give the notes in the description. Next is hardware software co-design and program modeling. So this is one of the very most important question that's asked in VTU exams as well as in the PYQs. Explain the fundamental issues in hardware software co-design. So there are four major steps. First one is selecting the model. Models are used for capturing and describing the characteristics of a system, and designers switch between a variety of models from the required specification to the implementation aspect. During the process of implementation, the designer changes the model based on the implementation about the system information about the system components as well as the method of implementation. And after selecting the model, the next one would be selecting the architecture. Architecture here would mean how the system is going to implement in terms of the number and different types of components. So commonly used system architecture would be controller architecture, which implements finite state machine model, also called as FSM model. We'll discuss in the next lecture about FSM model. And also state register, that holds the present state and the combinational circuit implementation. And the next type of architecture would be data path architecture. It represents a channel between the input and the output, and it's mainly represented by using the data flow graph. And ports are connected to the data path along with the multiple buses. For high performance, the arithmetic units are connected in parallel with the pipelining support. And the third type of architecture would be finite state machine data path, which combines the controller architecture as well as the data path architecture. The data path contains two types of I/O port, that is One acts as control port and second acts as IO port interface. Data path is implemented in a chip. And next would be CISC architecture, that is complex instruction set architecture along with its computing. In first module I have discussed the difference between CISC and RISC architecture. You can watch that video. Next one would be data path for CISC processor is very complex as it has multiple instructions in a single command. And data path of RISC architecture contains large register file for storing the operands and the output. And another type of instruction would be very long instruction word, also called as VLIW. It implements multiple functional units in a single data path. And one standard instruction for a functional unit of data path is packed in the very large instruction word instruction. Next one would be parallel processing architecture, in which single instruction multiple data and multiple instruction single data are the examples of parallel processing architecture. Next one would be, after selecting the architecture, the third step would be selecting the language. A programming language captures the computational model and also maps it into the architecture. The multiple programming languages could be C, C++, C Sharp as well as Java for software implementation. For hardware implementation, it would be VHDL, System C as well as Verilog. Next, you have to partition the system requirements into hardware and software. Various hardware-software trade-offs are used for matching the decision of hardware-software partitioning. So now we'll discuss about the computational models in embedded system. First one is data flow diagram or DFG model, in which you can see A and B are inputs to the addition block, as well as the output of the addition block X is given as input to the subtraction block, and it also has another input C, and the final output is Y. So the data flow graph operates based on the data or process and is represented as a circle. The process is represented as circle, and the inward arrow of the circle represents the input, and the outward arrow from the circle represents the output data. And DFG model is represented by equation also, x is equal to a plus b and y is equal to x minus c. And the next model would be control data flow graph or diagram or CDFG. It is used for modeling applications involving conditional program execution. Similar to the DFG, in CDFG it is based on the output is based on the certain condition. So here you can see, if flag is equal to 1, if it is true it will move further, if it is false it will directly go to the subtraction block. So this is control data flow graph or diagram, in which the control lies only based on the condition, and if flag is 1 then a plus b is equal to x, and else a minus b is equal to y. So diamond block is the decision making element or the control node. And next one would be state machine model. This model describes this system behavior with states, events, actions as well as transition. So state is a representation of element situation and element's current situation, whereas event is an input to the state. It acts as a stimuli for this state transition. Transition is the movement from one state to another, whereas action is the activity to be performed by the state. Also, FSM model is one where the states are finite, and consider the example of seatbelt warning system.